Hey, everybody. So we are going to talk about a so we are going to talk about a very interesting topic today. We're going to talk about vibe coding. And in the keynote, in the prior conversation, this came up a handful of times. And there's a lot of concerns with it, right? With people just asking these AI tools to write code and then try to ship it to production. There's been a lot of public issues as well with production databases being deleted by these AI tools when people are vibe coding. So how could you ever get yourself into a position to trust any part of this? Well, what we're going to talk about today is my journey, not necessarily vibe coding, but using a lot of AI tools in order to get my job done. So this is how it's been going for the last 2 years, some of the tips and tricks that I've come up with, some tools that I've developed, some things that I've even open sourced. And this is going to be a slightly more technical version of the prior talk where we're going to do demos and we're going to get a little bit further into the weeds. So it's going to be a lot of fun. So yeah, again, my name is John Zeolla. Like I said, I'm the founder of a company called Zenable where we work with AI tooling for developers. I'm also a CNCF ambassador. What that means is I have a giant pile of stickers in my bag and I'm happy to give them out to anybody. When you're an ambassador, one of the things that they do is it's a volunteer responsibility, and I try to coordinate people who use projects in open source, particularly like the Kubernetes ecosystem, and connect users and maintainers and get feedback to the right place and just kind of facilitate questions and answers and things like that. But then again, I do have lots of stickers, I promise. I think we covered the other things here. I also come from Pittsburgh, Pennsylvania. So if you hear me say the word yins, that just means you all, you're all. Let's get started with what is vibe coding, right? So if we go way back to February of this year, which is way back in the AI world, we've got a tweet from RJ Karpathy, and it says, there's this brand new kind of coding I call vibe coding, where you fully give into the vibes, embrace exponentials, and forget that the code even exists. So this is really like the origin of this term vibe coding. And the idea is that you're using an AI tool to generate code, and you're not necessarily reading the code or evaluating it line by line. Instead, you're kind of testing it, right? You're going off of a vibe. What vibe does it give you? Does it feel right? If you skim the code, does it look like the patterns that you want it to have? When you run it and test it, does it actually do what you wanted to do? So you kind of like jump to the end. You jump right to what we call end-to-end testing or integration testing. And you kind of see, does that work? Is that functioning the way that you expect? And there's a lot of people that are really huge fans of vibe coding. Here we go. We've got a post. Claude 4 just refactored my entire code base in one call. 25 tool invokes, 3,000 new lines, 12 new files. It modularized everything, broke up spaghetti. It was beautiful. None of it worked, but boy, was it beautiful, right? So this is a very common pattern, right? These AI tools are meant to be, if nothing else, convincingly good. This is confabulation or a hallucination. It looks great. It feels right. And if you're vibe coding and you're just going off of feels, you can end up with something that works, kind of, right? And by works, I kind of mean like it works just in the same way that this works, right? So does the water go down the pipe? Yes, the water goes down the pipe. So if we vibe code something and it actually looks like this under the hood, great. You might ship that thing to production. It's working. Your vibe tests, checked out, and then something changes, right? You have an increase in water flow or a decrease in water flow, or something else changes, and the whole thing is a house of cards that's just, just falls apart, right? And so one of the things we have to remember is that we have these AI tools, and they're trained. I like all right. So a quick sidebar. I love AI. I also have an obsession with watching YouTube. So I spend a little bit too much time on YouTube. And so what I try to do is kind of combine the two. And I end up watching a lot of YouTube about AI, right? Learning classes and things like that, but also fun videos. I'm going to show you a couple fun videos about training these AI tools so you can kind of figure out and get a mental picture for how they work. So here we're going to try to train some AIs to walk. We got audio. Yeah, not working so hot there, right? All right, we're trying. We're trying. It starts off kind of random. Let's progress a little bit. We'll jump a little bit forward. Okay. Oh, yeah, but this yellow one, the yellow one's making a little bit of progress. Okay, so we're starting to get a little bit better. And then, what if we give it like thousands of iterations and we just really, really, really get this thing to work? It might look a little something like this. It's walking. I mean, for some definition of walking, I'm not sure, but it's, oh, whoops. All right, so we're making some progress. We're kind of able to walk down the path a little bit. And if you think about like these AI tools, we're training them to do something, to walk like this, right? But we have some sort of a loss function, something that we're optimizing for. And if we look at another scenario, we might be like optimizing for how fast it can run. And so for this video, we're kind of gonna train an AI and we want it to run as fast as possible. And it's gonna start out a little bit something like this, but after a little bit of training, it could look like this. Now, that might look funny to you, but let's measure the result. All right, so Usain Bolt was able to run that in 9.58 seconds, and that thing with its hands waving in the air was just able to do it in 7.38. So if we purely measure this based on the results, that's a really good result, right? We've shaved more than 2 full seconds off of world record pace with that AI. Awesome. So that's what these AI tools can do. They're gonna work in a way that's slightly different than you might expect, but they can provide really impressive results. Now, I could end it there, but I feel like I have to give you a couple more videos. I'm sorry. Let's look at how AI can bowl. Impressive. All right, good form. Oh, however, there we go. Yeah, it's got the results. And let's move on to a little bit of table tennis. What does this look like? Okay, yeah, but hey, it's going back and forth and back and forth. It's probably doing a better job than I could do. Now, I probably wouldn't fall on my face at the end, but maybe I would, who knows? So that's kind of like how these tools are working under the covers. They can give you these results. They are even really good at being convincingly good, but they're going to do things in a slightly different way than you might expect. So if we had to break all of this down and you wanted to go use AI tools, or you have a team of people using AI tools, kind of how do you get started and how do you mature along the way? Well, the first thing is to build a baseline. One of the things that I noticed is that if you start an AI tool with an empty folder and you say, hey, I want to write some code, I want you to do this thing, A, B, C, and D, you explain it and you say, get started. It's going to do things horrendously bad, right? It's going to make an absolute ton of mistakes. And what prevents most of those mistakes is giving it something to work with at the beginning, making a baseline, right? If you're familiar with DevOps or DevSecOps, you've probably heard of the term paved road, right? Where you build a foundation and you allow people to kind of like walk on the road. You can see we're like building our foundation over here. We're gonna have guardrails in a second. But so what we wanna do is we wanna build the repository design. We want to say the folders look like this, the files are designed this way. Here are the tools that we're gonna use for testing, and we wanna implement a couple of tests. What's not important is that we implement a ton of code or anything by hand. All we're doing is making a baseline pattern, which then when we ask the AI to do more things, many, many, many more things, it can follow these existing patterns. We also want to write instructions. There are different roles or instructions, ways to instruct these AIs on how to follow the patterns that we prefer. And you need to pass those in early, right? So we want to say, this is how we do things here. We're going to write code with PyTest, and we're going to write all of our stuff in Python, and we're going to build it and put it in a Docker container. And then we want to do things like pipelines. We're going to do CI, continuous integration, continuous deployment, or delivery. We want security scans. We want to put all of those basic things in place, and then let the AI take it from there. And of course, we're going to have some checks and guardrails and human in the loop validation and things like that. But if you start with a baseline, you can go pretty far. And so we're actually going to look really briefly. I'm going to give a demo of an open source project that I made called AI Native Python. And what AI Native Python does is it builds a foundation. It builds that baseline for you almost 100% automatically. So if everybody can see that all right, we're going to kick off our demo. And this is going to be a Python project. And I'm going to call it CloudSecNext 25. And you can see on Docker Hub, there's essentially nothing here. At the end of this, in a couple of minutes, we're going to have a fully functioning Python application in Docker, which had CI/CD, security scans, validations, linters, checkers, fully deployed onto Docker Hub and working. Right? And the way that we're going to start is we're going to run this one command. And this is essentially a copy and paste command that you just take off of the project. We're going to run a AI native Python. And we're going to have to answer a couple of questions. So what do we want to call it? Well, we're going to call it CloudSecNext 25. CloudSecNext, whoops, SecNext. All right, so that's our description. We're going to call it John Zeolla, johnzeolla.com. So we have to answer a couple of questions. Where is this going to be stored on GitHub or things like that? I'm going to be the owner. Which version of Python do we want? I love the newest shiny thing, so we're going to go with 3.13. And we're going to say, yes, we are going to have Docker Hub support. We're going to make this a public project, and it's going to be MIT licensed. So I answered 11 questions, and now it's doing some work, right? It's building this paved road for us right now. And there we go. Give it another second, and it's fully functional. We have not only built all of this code, we have documentation, we have tests, we have pipelines, we've got a whole bunch of great stuff. We've got those instructions that we were talking about. And in fact, if we just take a quick poke around at what we created, right, all we did was answer 11 questions, right? It was pretty trivial, and most of them I just hit enter for, right? But what we've got in this project is starter code, and we have this kind of not implemented error, which is on purpose. This is the place where you put the code. So you say, hey, AI, look at this code base. We have a not implemented error. Implement the code there. Like very simple like that, right? We've got all kinds of things built into this project. We've got linters and checkers. We can prevent hard-coded credentials and secrets. We can check links to prevent incorrect URLs being generated. We've got things like truffle hog and all kinds of different stuff, right? I think there's like 20 or 15 or 20 different tools that are automatically going to be happening every time you make a change to this repository. These are guardrails that make sure that AI is on the right track. You could see if you want to look at all the files, there's a whole bunch of really good stuff here. This is an open source project, so obviously you can all look at it. We've got GitHub Actions, and these actions do a lot of really cool things, including the ability to release publicly, to create releases on your GitHub, but also to run security checks and to automatically update itself. Who here loves updating dependencies? I think literally no one ever has said that they like updating dependencies. So what's great about this project is it's going to automatically update itself every Monday and Thursday. Now, you don't have to accept the updates. It's going to open a pull request, but you could just automatically update regularly. And if you have tests that you believe in, you don't need to think about these dependency vulnerabilities from old dependencies. You might need to worry about new dependencies, but old dependencies, right? You're just going to be constantly updating itself. On top of that, we've got 100% test coverage. So whenever we write code, when we have the AI write code, we can say write tests, and it knows where to start. All right, so what we're going to do is we're actually going to run this release pipeline. And in the background, now it's going to do a bunch of code stuff, and it's going to build and deploy this thing onto Docker Hub. I'm going to skip this command just for time reasons, but in the future, we'll be able to run that command and it'll work, right? Once this pipeline is finished, we can see that it's creating a release and it's going to publish that Docker image. All right, so this is where things get interesting. What now? So I've made this baseline and I want to use AI to change something in it. Let's just use Claude. Claude Code is one of my favorite things. See, we've got an MCP server set up and connected. We've got some hooks and they're in there. Great. Okay, great. So all I did was change into this directory and hit Claude, right? Type Claude. So let's add a feature to source main.py. I want to connect to a Postgres database. Whoops, Postgres database. We can just hard code the creds for now in a variable. We will fix it later. Okay, right? So it's fine. I'm a developer and I'm just kind of short-term focused. We're going to have some credentials, but we have to put them in somewhere. I don't want to figure out, HashiCorp Vault or parameter store or secrets manager or any of that sort of stuff. I'm just going to, just a short-term thing. All right. So it's going. It's like, all right, yeah, yes, sir, I will help you out. That's a great idea. Let's add this. And you can see that it's doing a number of different things. It's going to implement this connect to Postgres function, and then we're going to get automated checks that run, right? And so what you can get is you can get guardrails as you're going. So as you saw, that was kind of like writing code, and then it's going to refine that code, and it's going to write some tests for that code. As it's iterating on that, in line with each file edit, you can run guardrails. And as was mentioned during the Q&A of the keynote, you can have both stochastic or non-deterministic guardrails, like an AI doing peer review, but you can 100% do what I would call policy as code or deterministic guardrails, so that you know with 100% certainty every time that you run it, you're going to get the same result. And that's the stuff that's going to run against the code that the AI generates, right? Our goal here is to put guardrails up so we are on the road, that we're not going off in left field, hard coding credentials, hard coding passwords or secrets or anything along those lines, right? So that's the AI native project, AI native Python project. It's open source. And my suggestion is to take a look at it and use it for inspiration. If you don't have a scenario where you can use this project, use the concepts and the examples from this project. It's meant to be an example project that's also functional, 100% fully functional, right? Now, that's building your baseline. What do you do after you have a baseline? Is anyone here familiar with the term spec-driven development, specification-driven development? Okay, handful of hands. So spec-driven development is a different paradigm that describes how you work with an AI agent to write code. And the idea is that you don't just say, like what I just did, you don't say, connect to Postgres and put it in a secret, put that secret in a variable. Instead, you take what's kind of a three-step process. First, what we're going to do is we're going to say, do some research. Find out how the code currently works and where the right place that you suggest AI, we make changes to add this new feature, right? So just do research. And then at the end of that research, you write it to a file, research.md, something along those lines. And then as a human, right, every step along the way, we can have human review. As a human, you go and you open up that file, you read it, and you say, oh, the research.md file says that we are going to do things A, B, C, D, and E. I like most of this, but this one thing I'm not a huge fan of. The AI made a mistake. You can actually just go in and edit this MD file and put the right suggestions in there. Then we build specifications. You ask the AI, you say, hey, we have this research MD. Go ahead and read it. This is the research from before. We now need to build some specifications. We're going to build descriptions of the requirements, acceptance criteria of our project. And it's going to write a second file. And then you actually do the implementation phase, right? At the end of all of this, at the third stage, now you say, all right, we have a specification and some research. Go ahead and implement what was suggested in those files. Now, there's all kinds of different ways that you can do this. You can make a PRD file, and you have essentially milestones. And what you want to do is you want to break down your changes, whatever they are, into multiple different steps. But the great part is we don't have to do that ourselves. We have the AI do it, right? We have the AI build this plan of what are the 10 steps to build this feature that I want. And then you can see there's multiple commits. We're going to do one commit for each feature. And we instruct the AI, every time you're going to do a commit, run some tests. Make sure the tests pass. Update the documentation and keep it in sync. So every single commit can be reviewed independently from a human. But also, if you remember back to my demo, when I ran a commit, when I actually saved the files, that big long list of checks came up, that like 20 things, right? If the AI is running commits, they are going to have those same guardrails. So as they're going and doing their work, it'll make sure that they never accidentally store something unsafe in the code or just do something that you don't want them to do. So you take this spec-driven development style approach, and then we can start working with tools and have a lot more confidence in their outputs because we've checked them early. We had them do research and we reviewed their research. We had them build specifications, we reviewed those specifications, and then we had them write the code. If you are, like we said before, just YOLOing the code and saying, oh, write it and ship it directly to production, that's not going to work out well, right? That's how your production database gets deleted, But taking an approach like this, much more reasonable. And maybe even you give them access to a sandbox environment that they can deploy to. Personally, I like to deploy that stuff myself, but I will let them run everything locally completely on their own. And so when we talk about specifications, there's actually a number of different ways to write those specifications. I'm going to very briefly cover two different choices, one called Gherkin, the other one called ears. And if you can see this, you see that it says, we have a feature, a create item, and a scenario. The happy path is that given we have a JWT in this payload, when I post this API, it does this. We're just describing an API, right, in words. And what Gherkin does is it guides us down the path of what information needs to be there to fully describe the scenario. This is a language that could be used for testing. I like to use it a lot for specification. So what you could do is you could say, hey, AI, when you're writing the specification, write it in Gherkin. It's going to know, typically, modern models are going to know what that means. And by having a format like this, a structured format, you can not only test it to make sure it has all the required fields, but you're going to force the AI to think a little bit more critically about what information it should include in that specification. Now, there's another slightly more complicated approach to a similar problem called ears. This is the easy approach to requirement syntax. And this goes way back more than 10 years. The idea with ears is that, 10 years ago, kind of pre-AI, more of like the machine learning phase, we needed to know what should go into a ticket, what should be shipped to passed to a developer to write some code or to the systems person, right? And they essentially came up with 6 different categories of requirements: ubiquitous, like this is always going to be true; event-driven, if this happens, then do this. You might have unwanted behavior. That's a big one for us security people, right? Never do this thing. This is an unwanted behavior. And so you can think about what your requirements are, the specifications of a system, and you can slot which of these 6 fit your scenario correctly. And you might have multiple different ones. You might have 10 unwanted behaviors and 5 state-drivens and an event-driven, and then 1 complex, right? These are just ways to describe the specification itself. And again, AI tools are pretty well versed in ears. You don't even have to spell out the acronym. You can say, write this in the ears format, and it will typically, if you're using a modern model, know what you mean. And so here's an example of that. Again, these are just sentences. These are just ways to describe the acceptance criteria of a task. So we're saying when an authenticated client submits a valid JSON payload like this, to post this, then do these things. And so we're going to build these specifications on what we do want it to do and what we don't want it to do. And then the kind of intersection of that is what's going to guide the AI to make an output that you agree with. And you know what you're going to find? Is that you're going to find that there's a whole bunch of stuff in your head that you assumed it knew that you never told it when you write specifications like this, right? That's something that I've been thinking a lot about. There's so much kind of context in our head, things that we never wrote down, right? Institutional knowledge, we call it, right? Things that we haven't documented. And this process is not, is one of the nice side effects of this process is that we are going to start writing down these things that are in our head, because we're going to be building them into specifications, acceptance criteria. Being a little bit more explicit with the AI also helps our peers. It helps other people know what we were thinking when we were approaching a project. So instead of saying, oh, did you finish that project? Yep, it works, it's all done. And that being all that you get, you could actually go back and look through and see specifications and requirements, what it's allowed to do, what it's not allowed to do, scenarios that have been thought through, and maybe scenarios that are missing. And you can add in additional scenarios over time and evolve an environment much more easily. And so at this point, we want to implement actual guardrails. These are kind of hard stops, things that are going to keep you on the road. And there's a number of different languages and ways that you can do this. I'm going to give just a sampling of them. But in the cloud native space, we have this concept of policy as code, right? And policy as code is you describe what you would like to be true and you enforce it like guardrails on a running environment. We can bring those exact same concepts and ideas into AI and large language models. And a lot of this boils down to what we would now call context engineering. So here we have Andre Karpathy again, saying +1 to context engineering over prompt engineering. This one he did not actually create. You can see this is a retweet of Toby down below. But once Andre says it, now it becomes rural, what do we all follow? So context engineering is, again, it's like the specifications I just described. What do we want it to do? What don't we want it to do? How do we feed into this machine what's allowed and what's not allowed? That's helpful on the stochastic side, right? Non-deterministic context. Context is for non-deterministic systems. And then you can create, in addition to this, policy as code based on that context, which becomes deterministic. And exactly like the question and answer of the keynote, this is that approach. You are mixing non-deterministic and deterministic reviews of the output of AI tools. I feel pretty strongly this is the right path to go. And here's a couple of examples. You could use a tool like ConfTest. There's a whole bunch of different tools in this ecosystem. But here, if we're making a Docker image, and we want to make sure that it only is ever from images that we allow, or it's never from an image that we don't allow, right? Essentially, it follows your rules. You can write this. You can say the values of the from cannot be in the deny list, otherwise fail. Right? Pretty straightforward. There's another language called GOS. So before we were looking at a file, this is going to look at an image, a container image, right? So if you've already built this image and maybe you're running it and you would like to assess it, does it listen for SSH or not? Does it have a file with this ownership or these characteristics? You can run different tools like GOS, here's an example configuration, of validating those SSH configurations. All you're saying is, these are the things that absolutely must be true in my environment. And then we've got another one called inspec. So inspec, if you were to deploy something into the cloud environment, say you're deploying it into a sandbox or a testing environment, and you'd like to make sure that it's following your compliance requirements, you can make a whole portfolio of checks that say, check for things like HIPAA compliance or conformance with your internal policies or whatever your SOC 2 attestation says, your ISO cert. Right? If you have these sorts of requirements, you can put those into code. You can absolutely use AI tools to assist with this. And then you run these deterministic assessments of them. So again, you can have this tight loop where AI not only is generating the code, but AI can run these guardrails and make its own changes, automatically respond to the findings of these tools so that you never end up with anything that's vulnerable. As the AI is running, it's automatically checking itself and making fixes. Now, is this going to be perfect? Absolutely not, right? And in fact, there's a whole bunch of now what, right? We talked about MCP servers. In fact, I did a quick demo of an MCP server there. You could consider that an agent. There are agents that you could do inside of your IDE, and we've got really complicated context. How do you know what your requirements actually are at your organization? And a whole bunch of other stuff. There's way more to this conversation. Unfortunately, my time is up. But that is how I would suggest getting started. If you want to get more comfortable with vibe coding or getting your arms around AI tools in your ecosystem, starting with building a baseline and putting guardrails in place, I would highly recommend doing that in a deterministic way as much as possible. So thank you.